So we took the top polynomial, we'll put it in our little division house. You take the bottom one, you put it outside, just like you do when you're doing normal division. Okay, and then first thing we do is we look at the first term here and the first term here. Okay, and we say, what do we need to multiply x by to get it to be a 2x squared? What do you need to multiply x by to get it to be 2x squared? 2x, yeah. X times 2x is 2x squared. So you write that 2x up top, and then you take that 2x and you're going to multiply it off this side. 2x times x is 2x squared, so you write that here. 2x times 2 is 4x, so you write that here. And then these two get subtracted. You do 2x squared minus 2x squared, and then you do 7x minus 4x. And what's 7x minus 4x? 3x. That's why there's a 3x here. And then how do you think we got this 6? We brought the next term down. Divide, multiply, subtract, bring down. And then you repeat that process, except now you're going to look at the first term here and the first term here. And you say, what do I need to multiply x by to get it to be a 3x? 3. So we put the 3 up top. And we take that 3 and we multiply it off the side. 3 times x was this 3x. 3 times 2 is 6. And then at the very end, you're going to subtract. 3x minus 3x is gone. 6 minus 6 is 0. So this one actually divides evenly, okay, because we got a remainder of 0. And the quotient is 2x plus 3. So 2x plus 3 would be the answer. They do not always divide evenly. Sometimes we'll have to write the remainder. Y'all ready to try one? It's not as scary as it looks. So I'm going to start by setting up my division. Okay, I need inside my little division house, we're going to put that top polynomial. When we write down the polynomial, you need to check if it's missing any terms. So you can see I have a cubed term, a squared term, a term with a variable exponent of 1, and then a term with a constant. So this top one's not missing any terms. If you are missing terms, though, you're going to have to put in a 0 for it. I'm pretty sure we're going to see that on 1 on the back. Okay, and then on the outside, we're going to put what we're dividing by. And again, if you're missing a term, you need to put in a 0. So like, say you have a cube term and a constant. You would have to put in zeros for the square term and the single variable term. But on this one, we're not missing a term. We just have one variable and then a constant of minus 2. All right, let's do this. So we're going to look at the first term inside. I believe that's called the dividend, its technical name. And then the first term outside in the divisor. And we're going to say, what do we need to multiply x by to get it to be 2x cubed? So x times what is 2x cubed? And Jay said 2x squared. Double check real quick. Yes, yes. So I'm going to take that 2x squared and I'm going to write it on top. 2x squared. And then I'm going to take that 2x squared and I need to multiply it off the side by both of those terms. 2x squared times x, 2x squared times negative 2. Okay, starting with, what is 2x squared times x? 2x cubed. And what would be 2x squared times negative 2? Negative 4x squared. Good. Okay, next up, we're going to subtract these two. We're going to subtract the first, and we'll subtract the second. Be very careful when you do your subtraction. Subtraction is the place where most people make mistakes. It's not on the algebraic long division. It's on baby subtraction. If you're going to make a mistake anywhere, it's baby subtraction. First row, 2x cubed minus 2x cubed. 0, cancels, right. And then we have 9x squared. I'm going to write it down. 9x squared minus negative 4x squared. What is 9 minus negative 4? 13, right. And guess what the most common wrong answer is? 5. So make sure you're doing that subtracting right. So that would be 13x squared. Okay, so we've divided, we've multiplied, we subtracted. Next up, we're going to bring down. We're going to bring down this plus 14x. And then we're going to repeat that process. Except now we're looking at the x that's on the outside and the 13x squared towards the bottom. And we're saying, what do I need to multiply that x by to get it to be a 13x squared? 13x, right. So I'm going to write that up top. I'm going to write 13x up top. We do have to have some sort of sign in between these two. We can't just leave it as 2x squared 13x. What sign was that, do you think? Plus, right, because it's positive. Okay, and then we're going to take just the 13x, and we're going to take that 13x and multiply it off the side. 13x times x is 13x squared, good. 13x times negative 2. 13x times negative 2. It's definitely negative. Negative what? 26x. Very good. And then what do I do with these two? Subtract them. Again, here's where you're going to make a mistake. If anywhere, feel free to write it down just in case. The first one's going to cancel. 13x squared minus 13x squared. And then we're going to have 14 minus negative 26. What does that turn into? 40, right, because that two negatives turn into a plus. So that's 40x. We got one last round of that, so we still need to bring down the 5 on this one. So we're going to bring that one down, plus 5. Okay, and we're going to repeat one more time. We're looking at the first term here and the outside term here. What would I need to multiply this x by to get it to be a 40x? 40, right. We're going to write that up top. We do have to write plus 40. Sometimes it's a negative, but on this one it was a positive 40. And then we're going to take just the 40 and multiply it off the side. 40 times x is 40x. Okay. 40 times negative 2. Negative 80, very good. And then we have one last subtract at the very end. 40x minus 40x cancels. We're going to write down our subtraction so we can visibly see. That says 5 minus negative 80. What's 5 minus negative 80? 85. Those two negatives turn to a plus. Do we have anything more to bring down? No. So we did get a remainder on this one. It's not like turning it into a decimal. It's not like you can like add a decimal and bring the 0 down or anything like that. So to write our answer, this is our quotient. We're going to start with the quotient that we got up top. 2x squared plus 13x plus 40. Okay, and it's going to feel very similar to how you turn an improper fraction into a mixed number. Let me remind you of how you did this way back in the day. So say you had 34 and you were dividing it by 3. Okay, you would say 3 goes into 3 one time. That's 0. You'd bring this down. 3 goes into 4 one time. 1 times 3 is 3, and you have 1 left over. How would you write this as a fraction? 11 and 1 over 3. How did we get 1 over 3? That's embarrassing, guys, that y'all can't. It's basically you're turning 34 over 3 to an improper fraction. How do we get this 1 over 3? It's the remainder. And what's on the bottom of it? The 3 that you divided by, right? So your quotient is the big part. And then you take your remainder, which on this one is a 1. You write that on top, over 3. It's the same thing here. Okay? We have our quotient. And then we're going to say plus, and then we're going to take the remainder, which is 85, and put it over our divisor, what we divided by, which was x minus 2. That's the whole entire answer, including remainder. It definitely uses a lot of prior knowledge math on this, of like things we've learned before, and we're reminding ourselves of that. All right, let's see. We've got a top polynomial. Again, we're checking to see, is this one missing any terms? We have a cubed term, a squared term, a single variable, which would be exponent of 1, and the one without a variable. Missing any terms? Nope. So I'm going to take that. I'm going to write it in my little division house. X cubed plus 2x squared minus 9x minus 18. And then we're going to divide that on the outside by x minus 3, which is also not missing any terms. Okay, so I'm starting with just the x outside and looking at the first term inside. What do I need to multiply x by to get it to become x to the third power? X squared. So x squared goes up top. And then we're going to take that x squared and we're going to multiply it by both terms on the side. X squared times x is x cubed. X squared times negative 3. Negative 3x squared. Good. And then what do we do with these two? Subtract. Pay close attention to what you're subtracting. The first one's going to cancel. The second one, 2x squared minus negative 3x squared. 5x squared. Two negatives turn into a plus. Okay, so we divided, we multiplied, we subtracted. Now we're going to bring down that minus 9x. Okay, now I'm looking at first term down here and my x that's outside still. What would we multiply x by to get it to be 5x squared? 5x. So on top we're going to write plus 5x. And then we're going to take that 5x and we're going to distribute off this side. 5x times x is 5x squared. 5x times negative 3. Negative 15x. Good. And then we're going to subtract. Remember, if you're going to make a mistake anywhere, it's on basic subtraction. Feel free to write it down so that you can see it next to each other. I think it's because we're not used to seeing subtraction stacked like this. We're seeing it literally written left to right. The first one's going to cancel. The second one would be negative 9 minus negative 15. And two negatives in a row become a plus. So what would be negative 9 plus 15? 6. So 6x. Okay, and then we still have one more term that's a negative 18 we have to bring down. Okay, so we're looking at first term on the bottom and our x again. What would we multiply x by to get it to be a 6x? Just a 6, yeah. Plus 6. We'll take just the 6 and we're going to multiply it. 6 times x is 6x. 6 times negative 3 is negative 18. Anyone else excited right now? Is it going to does it divide evenly or do we get a remainder? It does divide evenly. If you're ever unsure, again, take this little subtraction here. Negative 18 minus negative 18. Two negatives become a plus. So that's negative 18 plus 18, which would be 0. So we don't have to worry about writing the remainder over the divisor on this one. The answer is just the quotient that we got up top. Anyone know what it means if you get a remainder of 0? Like what else that means? It does divide evenly, yes, but it also means you could have factored it. It was factorable. Anytime you get it, divides evenly. Alright, anyone notice what's different about the top on this one? It's missing a term. Okay, what term is it missing? The x. Yep. Missing a term. Anytime it's missing a term, I would write in a 0 as a placeholder, like write 0x for it. So inside my little division house, we're going to write 2x cubed plus 3x squared. We're going to put that missing term, that's 0x, and minus 7. Okay. The only reason for this is because otherwise when you do your multiplying off the side and then subtracting, everything will be slightly misaligned if you don't put in that placeholder 0, and you'll get confused. You're like, wait, how do I subtract x squared minus x? Oh, that's because it's not lined up properly. So we put that 0 in to keep it lined up properly. Are we missing a term on the outside one? No. This one's also a trinomial. Remember I said at the beginning, we often do binomials, but yes, you can divide by a trinomial. Alright, we're looking at first term inside, 2x cubed, and the first term outside. What are we going to multiply x squared by to get it to be a 2x cubed? 2x, right. So we're going to take that 2x and put it on the top. Off the side, we have to distribute to all three of these. 2x times the first, the second, and the third. 2x times x squared is 2x cubed. 2x times negative x. 2x times negative x. That's negative what? 2x squared. Good job. And then 2x times negative 2 would be negative 4x. Good. Okay, be careful when you subtract. We gotta subtract all three, and I would highly recommend writing it down as regular subtracting. First one's gonna cancel. That's 2x cubed minus 2x cubed. Cancels. And then we'll have a 3x squared minus negative 2x squared. 3 minus negative 2 becomes 5x squared. And then we'll have a 0 minus negative 4x. 0 minus negative 4 becomes 4. Yeah, positive. Plus 4x. Okay. And then what's my next step? Bring down the minus 7. Okay, we're looking at first term on the bottom and our term outside. What do we multiply x squared by to get it to be a 5x squared? A 5. So we'll write plus 5. And then we're going to take just the 5 and distribute it off the side. 5 times x squared. 5x squared. 5 times negative x. Negative 5x. 5 times negative 2. Negative 10. We're going to carefully do that subtraction. Okay, I know first one's going to cancel. The whole point was finding a number to get it to cancel. And then we've got 4 minus negative 5. 4 minus negative 5 becomes 9x. Yep. And then we have negative 7 minus negative 10. Two negatives become a plus, so that's negative 7 plus 10, which is 3. Right. Plus 3. Do we have any more terms to bring down? No. So this binomial is our remainder. So to write the answer, we're going to start by taking the quotient up top, 2x plus 5. And then we'll say plus, and then remember what we do. We take the remainder and we write it over the divisor, what we divided by. So remainder goes on top, 9x plus 3, over the divisor, which was this whole thing that we divided by, x squared minus x minus 2. All right, let's take 30 seconds real quick. I want you to talk to your group, and I want you to explain the process of long division and also tell your group where the most common mistake is going to be. So tell them what is the process of doing the long division and where you're going to make mistakes. I'm going to take attendance while y'all do that.
I think she might know. But I mean, eventually, like, you know what the yeah, I don't think. Yeah, because I didn't really know. I don't get the difference. I have no idea. But Miss Bruce was like on
Alright. Everybody feel like they understand? Next up, remainder theorem. Oh, what are we doing in Kim? Escape room. Oh, okay. That sounds like fun, but it's probably not. Chemistry-based escape rooms. I would be stuck in there forever. Okay. Remainder theorem is something, it sounds very technical, but it's not not too shabby. It's not really hard to do. Says if a polynomial p of x, okay, so some sort of polynomial, if it's divided by a binomial, then the remainder is actually equal to what you would get if you would have plugged in like the solution to this. Okay? So what it's saying is so say you have some sort of polynomial like x squared minus x plus 2, and you want to divide it by x plus 5. Okay? It's saying that if you take the solution to this little factor, so if you took this factor, set it equal to 0, and solved it, what would be its solution? X equals -5. So it's saying that the remainder that you would get if you actually did the long division is the same number that you would get if you just take this -5 and plug it into the formula. So if you take this -5 and plug it in here, we would get -5 squared minus -5 plus 2, which would be 25 plus 5 plus 2, which is 32. So if we actually did the long division, our remainder would be 32. That's really all the remainder theorem is. It's just like, oh, okay, that's a cool party trick, I guess. If the remainder is 0, okay, that means that x minus k is a factor of it. We kind of talked about that earlier. We got a remainder of 0 on this one, so that means that x minus 3 is actually a factor of it. Okay, so on this one, our little example here, it says, given that f of x is equal to 2x to the third power minus x squared plus 3x plus 6, determine if x minus 4 is a factor of f of x using the remainder theorem. Okay. So that means we want to take this x minus 4, we want to set it equal to 0, and we want to solve it. What would I get for the solution? 4. Very good. Okay. So again, what we just discussed, we said that if you take it, set it equal to 0, and solve it, that number plugged in will tell you what the remainder is. And if the remainder is 0, what does that mean again? If the remainder is 0, that means, we just read it. Akshar, y'all paying attention? Thank you. If the remainder is 0, what does that mean again? It is a linear factor. Okay, so I want you guys to turn. Let's work with our groups on this one. Let's plug it in. Let's see what we get. Okay, and that'll help us determine whether it was a factor or not. All right, turning, plugging it into our groups. Don't touch those calculators. We got this. Are y'all plugging in? So then we're checking for when we plug it in, what would be the remainder? Well, we did it the hard way. You could have just plugged it in.
Nice.
So we're taking this, and we're going to plug it in right here for x, and see what we get for the remainder. You can write it down, you don't have to do it. Again, once you get your remainder, we want to turn it and tell our groups that means it is a factor or is not a factor based on what the remainder was. You plug it in. Take 4, plug it in here, here, here. Oh, Max got it. What does that mean, Max? Okay. Let's do about 30 more seconds. What did you get? What you thinking about? I would start, you can do these in any order you want to. So you can do like this one and this one first, and then combine these two. Oh, alright, Jade. Based on that remainder, what does that mean? Good. 10 more seconds.
Yeah, I did something wrong. I don't think you might as well don't. Where does this 4 squared is 8?
Alright.
No, 4 squared is 6.
Let's come back together. I saw lots of right answers walking around. At the very end, you should have got something that looked like 48 minus 48 when you simplified it. And what is the answer to that? 0. So what does that mean? Was it a factor? Yes, that means x minus 4 was a factor because we got a remainder of 0. X minus 4 is a factor. And the most exciting part of all of this was on the SAT test. Look at that practice SAT question. Yeah, crazy, right? Some really obscure topic is on the SAT. Let's look at it. For a polynomial, p of x, the value of p of 3 is negative 2. Which the following must be true about p of x? X minus 5 is a factor, x minus 2 is a factor, x plus 2 is a factor. The remainder when p of x is divided by x minus 3 is negative 2. Let's do about 30 seconds. Let's turn and talk to our group real quick. What does that mean if p of 3 was negative 2? That's right. That's true. You didn't get 0. What does it mean?
X plus 2 is when you solve it.
It means you circled already. X literally yeah. Alright, let's look at it. So make sure we all got the right thing. The fact that they got a remainder. I heard Max Jacobs say it again. What does that mean, Max? It's not a factor. So we don't want to pick anything that says it is a factor. We want to pick the answer that says they got the remainder of negative 2. So it would not be a factor. Oh, hello, timer. All right, let's go ahead and get going on our DOL. I'm going to come around.